Hello, I've had a question in Unit 4, Lesson 6, and this is the second half or part 2 of the homework. I'm looking at question 37. It says find the volume of a cone of maximum value inscribed in a sphere of radius r. So I'll sketch myself. Here's my sphere. I'm going to put a cone inside it, and I don't know where the base of that cone is going to end up. So I'm going to call it right about there. So just fill that in. Okay, so with this, we know the center of the sphere touches the peak there. So that'll be a radius. And if we go out to one of the bases there, we know that's the radius. The remaining part, we don't know how far it goes down to here, so I'm going to call that x. And we know the base of the cone is small r. Alright, so I'm going to use small r. So a couple of things to note here. First of all, capital R is a constant. Alright, next, the constraint equations are as follows. So we know that for this particular cone, we know the height of the cone is going to be the large sphere, so this part right here, plus the radius, oops, wrong pen, plus, oops, not, sorry, so to be plus the x value. Alright, so there's what our height is going to be, so there's our first constraint equation that we're going to use. Next, kind of need to know the relationship with x. So when we look at it, we have a Pythagorean triangle, or sorry, a right angle triangle here, so we use Pythagorean theorem. So I can say that capital R squared is going to equal that remaining height squared plus r squared. Now we're trying to optimize. I'm going to jump over here. We're optimizing volume. So volume of a cone is 1/3 pi r squared h. So I already have the h term taken care of. That's just capital R plus x. Now note, I need r squared. And I have r squared here. So I'm just going to rearrange it to get small r squared equals capital R squared, radius of the sphere, minus x squared. So now I have that all in terms of x as well. So that can go up to that volume formula. So I end up with volume equals 1/3 pi. R squared is capital R squared minus x squared. And the height is r plus x. I'm going to clean that up. So I'm going to have to use FOIL, or my distributive law here. So I'm going to end up with r cubed plus r squared x minus x squared r minus x cubed. Alright, so I just have power rule there. So I'm going to go ahead and take the derivative of the volume with respect to x. So I'm going to leave the 1/3 pi out front. It's common to all of them. R cubed, remember, r is a constant. So when I take the derivative of r cubed, it's 0. Plus the derivative of x is 1. So I'm left with r squared minus 2xr minus 3x squared. So if I let the volume with respect to x equals 0, 0 equals 1/3 pi, and I'm left with r squared minus 2xr minus 3x squared. 1/3 will disappear, going to divide both sides by 0, and I'm left with, I'll shrink that down just a little bit to help myself out. I'm left with 0 equals, I'm going to move the x squared to the other side to make it positive, 3x squared plus 2xr minus capital R squared, so I just rearrange the equation, equals 0. And now we have a quadratic function to solve for. So that means I can use quadratic formula. So x equals negative b, so it'll be negative 2r plus or minus the square root of 2r squared minus 4 times 3 multiplied by, and our c term is negative r squared all over 2a, so 2 times 3. So I'm left with negative 2r plus or minus So that's going to give me 4r squared plus 12r squared over 6. So that's negative 2r plus or minus. 4 and 12 is 16, so the square root of 16r squared is 4r. And that's all over 6, which means that when I reduce that, we end up with either 2r over 6 or negative 6r over 6. Oops, yeah. And because this is a negative, it's inadmissible. We can't have a negative value. So that means that our answer is going to be r over 3. Oops. So our answer then for this question is that the x value has to be r over 3. So now we're just substituting back in to find the missing values. So coming back up here, we'll find that h equals r plus x. So that's r plus r over 3. So that would mean that the height is equal to 4r over 3. And r squared is equal to r squared minus x squared. So that would be r over 3 squared. So again, need to shrink that down, make that fit. So that would mean that r squared equals, so it would be r squared, that would be r squared over 9, so it would be 8r squared over 9. So moving over here, our final answer, volume equals 1/3 pi r squared h, which would be 1/3 pi. R squared is 8r squared over 9, and the height we said was 4r over 3. Cleaning that up, across the top, we're going to end up with 32 pi r cubed, and on the bottom we end up with 81. So there is the maximum volume that will fit inside a sphere. So definitely a little bit more challenging, but they all work the same. So if you have any questions without or need clarification, let me know.